Welcome. This video walks you through a model that parses out a name taxonomy from commingled and unstructured text. The model is called cust_num and it predicts the following entities. Name prefix, which is name prefix and name prefix 1. First name that goes through fname through fname3. Middle initials, which is middle initial and middle initial 1. Last name that goes through lname through lname 4. Corporate suffix that goes through corporate suffix to corporate suffix 2, apart from miscellaneous and others. The data that is being used in this video is the same as is used in the other advanced algorithmic server and WireMDM videos. This data is global, commingled, and completely unstructured. A critical aspect to note about this and the other models is not just the entities that are recognized by any given model, but also the lack of false positives. For example, this model is supposed to pick up names of individuals and corporations. At the same time, it does not pick up bank names as names from instances where bank names are present in the string, thus proving the robustness and the efficacy of the model in handling commingled and unstructured text. Running test recognize on this data sets gives the following result. As you can see, there is a smattering of colors here which depicts those entities that are eligible to be recognized as individuals or corporations. The entities present in this data set are only corporations and bank names. Let us look at the XML renderization of the file. The very first record is a corporation. A corporation is denoted when the corp suffix has been picked up. So if a name has a corp suffix, then it is a corporation. If a name does not have a corp suffix, it is a name. In this instance, we have Paramount Export Company care of ASL Mauritius Limited. So this entire string has been picked up as a corporation. Another model can be created to further parse this out into two distinct strings or two distinct entities. So one could be Paramount Export Corporation, the other could be doing business as ASL Mauritius Limited. So there could be another model which is implemented downstream to further break out the name. Here similarly, this is the corporation suffix has been picked up. So Sunflower Company is a corporation. Likewise, auto sales is a corporation suffix. So Triply Auto Sales is a corporation. Technologies is a corporation suffix, and therefore Advanced MP Technologies is a corporation. This is what I was talking about earlier. This model is smart enough to distinguish between when a name occurs and it's a bank's name, and when a name occurs and it's an individual or a corporation's name. In this instance, First Caribbean International Bank is obviously a bank. The model categorizes this whole string as miscellaneous. Likewise for Almond Bank, Bank of New York Mellon, Bank of China, and so on. And here we come to Mehtab Trading Corporation. Here again, the corporation suffix has been picked up, so therefore Mehtab Trading Corporation is designated as a corporation. Similarly with Flextronic Tech Shanghai Company Limited, the corporate suffix have been picked up here, so this whole string is a corporation name. Essentially what happens is that when a corporation name is picked up, the metadata which underlies this model will have a flag which will say that this name belongs to a corporation. And when an individual's name is picked up and corporation suffix is not picked up, the metadata underlying will say that this is an individual's name, and likewise it's a bank's name, and so on and so forth. Therefore, this proves the efficacy of this model. This is an early renderization of this model. A lot of training is required to make this model more robust. Against completely unstructured Swift kind of data, it gives reasonably good results, but against a more structured client data, it works really well. Thank you for watching this video. Goodbye.